missing non-negative integer after operations. So for this problem, we are giving a zero index integer array nums and an integer value. And in one operation, we can add or subtract value from any element of nums. So for example, if nums equal to 1, 2, 3, and value is equal to 2, you can choose to subtract value from nums 0 to make the nums negative 1, 2, and 3. So we can do that. We can use 1 minus 2, or we can use 2 minus 2. So for each of the numbers, that is okay. We can do such kind of operations, and we can do as many times as we want. So the MEX, minimum excluded of our array, is the smallest missing non-negative integer in it. So for example, negative 1, 2, 3, and we can make it to 1, 0, and 3. Because we're going to plus a 2, make it 1, and for this one, we're going to minus a 2, 2 minus 2, it's going to be 0, and for 3, we're going to keep it. So 0, 1 we have, but what is the missing non-negative integer? It is 2, so that means we're going to return a 2. So we're going to return the maximum MEX, just to ignore this MEX. We just need to return the maximum of nums after applying the method operation any number of times. Yeah, so in the first example, we can make something like 0, 1, 2, 3, 6, and 8, but we cannot make it 4, so we're going to return a 4. Yeah. So if we are giving such kind of problem where we are giving an array of nums and we are giving a value, and we can do such kind of a plus or minus value with all the number inside of the nums array. So basically, this is a modular problem. Yeah. So what are we gonna do? We just need to check the modular. So for example, 1 modular 5 it is 1, negative 1 modular 5 it is 0, and 6 modular 5 it is 1. So what is the difference for this 1 and 6? Because 1 modular 5 is 1 and 6 modular 5 is 1. So normally we're gonna use a dictionary to solve the problem. So if the k equals to 1, definitely we're gonna put a value 1 and 6 inside of the array. But actually we don't need to do that. We just need to use a counter. So for 1, we're gonna count it as 2. So this means for all the numbers, we're gonna have a remainder. We're gonna have a modular. After the modular, it's gonna be 2. So it means we can choose the values like 1 and 6 if the value is 5. So if we understand the problem like this, basically we already know how to solve the problem. Let me just start coding and to explain more about it. So we're gonna prepare a counter, and instead of preparing a list, we're gonna use integer, because integer can solve the problem easily. We just need to count it how many remainders like 1, 2, 3, or 4. So this means we're gonna choose the number more and more. So for any number inside of the nums, so for the dictionary, we're going to use this n, and with a modular. This is really important, because otherwise, how can we solve the problem in O in time? We have to use this modular. So, gonna plus equal to 1, and now let's just check what is inside of this counter, inside of the dictionary. Now let me just give a random return 0, and let's just check what is inside of the dictionary. So for the first example, let's see what is inside. If the remainder is 1, we're gonna have 2 numbers. If the remainder is 0, we have 1 number. If the remainder is 2, we have 1 number. If the remainder is 3, we have 2 numbers. So this means from 0, definitely we can choose 1, and then we're gonna start with 1, 2, and 3. So what about 4? And there's no 4. So this means our return gonna be 4, because we cannot find it. Yeah, so this is exactly how can we understand the problem. We're gonna prepare such kind of a hash table, and we're going to use the hash table to solve the problem. Yeah. Now let's just check the second example. So for the second example, as we can see, the remainder, the value is 7, and the remainder 1, 4, 1, 4, 0, 6. First we have a 0, right? It is coming from here. Now we're going to check 1. We have a 1. So what about a 2? So we don't have a 2. So that is why we're going to return a 2 from here, because we cannot find it. Yeah, so this is the idea how we're gonna solve the problem. Yeah, even understand from the examples, but there are gonna be more testing cases about it, and let's just start programming and to find more about it. Yeah. So what are we gonna do? We're gonna check the nums one by one. We will not check the nums one by one. We're gonna check the values one by one. Yeah, because definitely the length of the array, the length of the nums is 10 to the power of 5. So for our return, it can only be 0 to 10 to the power 5. So this means we're going to enumerate all the values and we're going to try to find the final result. So for I in range from 10 to the power of 5 plus 1. Because 10 to the power 5 is the maximum possible value. Because, you know, if the array's length is 10 to the power 5, so what's going to happen? So the length of the array is 10 to the power 5. So this means if we have some values like 0, 1 to something, to which number? So it's going to be 10 to the power 5 minus 1. But for us, we need to what is missing? The missing number is 10 to the power 5. So this means we're going to choose the maximum number, I, 10 to the power 5 from here. Yeah. Now what are we going to do? We're going to take this I, but we will not use this I directly. We're going to use a modular, because from here, we turn all those numbers, possible cases, as a k, and this k is going to be a modular. So first of all, we're going to prepare a modular. So the value is going to be I modular the value. Yeah, so we're going to choose this value. So if the val inside the dictionary, so what are we going to do? So we're going to update the counter. So d with this value going to minus 1. So if d with this value equal to 0, this means we're going to pop it out. So we're going to pop out this k. Yeah. But if this value is not inside of the dictionary, what are we going to do? Yeah, because this dictionary is just a counter. So if it is not inside, definitely we're going to return the I, and this I is going to be the number. Yeah. As you can see, it is not so difficult, and everybody can learn about it, and everybody can grasp this kind of algorithm. We're going to call it just a modular algorithm in mathematics. Yeah. Normally we're going to use a hash table to solve it, and this is not something we need to remember. It is just this kind of idea. Definitely we're going to use this kind of idea to solve the problem. Yeah. Now let me just submit it. As you can see, it works. And the time complexity is just O(n). As we can see from here, this is O(n), and another one from here, this is also O(n). And the space complexity is also O(n). Because we prepared this dictionary, definitely we're going to use it, and it might be possible to use all the numbers. Yeah, I think that's, yeah, let me just run it. Yeah, I think I've already submitted it before, and I think that's all about it. Thanks for watching. See you next time.